do that here. All right, last comment. So we did last week a diagram where I had my host PC here, and I was connecting over here to a server that is also a host. And we were having, let's say, a switch in between.
The whole thing isn't in the frame.
That's all right. Sorry about that. Well, that's interesting. The little tape isn't lined up. Sorry, dude. I'm not watching the screen. The other thing that happened 2 weeks ago is I managed to mess up my back from sitting in a funny posture. All right, I got a switch here. This is going to be a router. I'm going to have, let's say, another switch. And let's put in a router just for fun. And then we'll go directly to our host. All right, so I have these devices along the way. We remember that over here on the host we had the application layer. I need to draw these a little bigger. We had the transport layer. We had the network layer is okay. Internet layer, then the data link layer, and then the physical layer. Okay, and we remember the physical layer is the cable. We'll be talking about that a million times today. So I got a cable there. Now, we also noted that at the switch has a physical layer connection. It needs to have a data link layer process in order to look at the frame and determine which port of the switch to send the frame out. The router needs to also have a physical layer, of course. It needs a data link layer because it needs to be able to unpack the packet, decide which different subnet it needs to go to, and then it goes out another port. We're going to connect to another switch that also has those two. I'm going to do another router because we can. And then we will, I probably should put a switch in here just to be more accurate. So we'll put in our switch here. And then the final host, if I can scoot that over a little bit. Brost, huh? Host. Doesn't that look like brost? I must have written brost. Okay, where are we at? Okay, and then this one will have all five layers. Physical, data link, internet, transport, and application. Okay, now that I've drawn this lovely diagram again, I'm only going to really make one main point, and that is, if we think about each conversation that happens here. For example, there's a conversation here that goes on between my computer and this first switch. Now normally this would be, let me change colors just so it's lovely pretty. This is going to be a one-way conversation, okay? I'm just going to send the data to the switch, okay? There's not going to be a two-way here. Remember when we were at some places we were thinking like we were going to say hello, the other person's going to say hello, we're going to listen for if we get an acknowledgement, those sort of conversational things. We aren't doing those here. Same with here. Okay? So between the switch and the router, it's just a one-way conversation. Right? I'll just go across here. The reason why this is only a one-way conversation, one direction, just like the band, right? So it's one direction. This will save overhead. Okay? That's our number one thing. There's no back and forth. Okay? So there's no back and forth. Okay? If we aren't going to have any back and forth, yes, we save overhead, but, and here's the other thing, we can't have a connectionless, or we can't have a connection, so we are connectionless, and at the same time, since there's no back and forth, we can't be reliable. I'm not going to get an acknowledgement back. So we'll put connectionless and unreliable. Okay. So if we just think about the data link layer, normally it's connectionless and unreliable. If we decided we needed reliability, every time we wanted to send something, we would sort of have to negotiate these connections along the way. Okay? So data link layer is connectionless and it's unreliable to save. We're saving two things. Because of the overhead, we're going to save some transmission speed. But the main thing we save here is latency. Because if you think about it, if this had to be a two-way conversation where we said hello as we talked, we'd have to say hello, hello before we could send any data. Those two little exchanges of hello adds a little bit of latency. The next stop, if we do that again, hello, 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 hello. Now I've added 1, 2, 3, 4, 5, 6 hellos, and that adds, obviously here, 6 times as much latency as we would even want. All right? So we are connectionless and we are unreliable at the data link layer. If we go up a layer, so we think about the internet layer, there's actually sort of a logical flow here between my computer and the router, between this computer and the next router, and that router to the host. The same rule applies. We do not have this sort of two-way conversation. Okay? So we are still going to be connectionless. I'll put an X here because we don't want that. We are still wanting to be connectionless and unreliable at layer 3 because that would add here 3 times hellos and add that much more latency. But if we get to the very top layers, the host-to-host layers, we only have one hop. So we'll call this host layers is basically going to be one, we'll just call it a conversation. Okay? So when it's host to host and it's a conversation between this computer and this computer, this is when it makes sense to start being reliable. Because we only have one set of hellos, so I only put one hello back. I'll put a green one here. So remember, I'm going to say hello and then hello back. If I'm only going to have one conversation at a time, one conversation makes sense. It makes sense to have connectionless and reliable. Okay? They call it connection oriented. So it makes sense at either the transport layer or the application layer to make this conversation and the reliability. Even if you think about reliability, if we were going to check for errors at each hop, it's going to take some time to check the errors and get the acknowledgments back. Okay? A lot of overhead. So these we call hops. Every time we go between a device, you call that a hop. So these lower layers, we call them hop by hop layers. And these top layers, we call them, I think we could just call them host to host or end to end. I think they're end to end. Okay? Normally, we only have one, and I'll just write it here. Normally, only have one reliable layer. Okay? So if I'm reliable at the transport layer, that means the transport layer is going to hand good data up to the application layer. So we're sure the application will get the data, the stuff it needs. Now just to make one more comment, some of you may have heard of BitTorrent. And the way BitTorrent works is I have my computer here, and I might be connecting to multiple different people to get pieces of a file I want. so a very large file like a movie, I need little blocks of the movie, and it'll be broken up into several sections. And let's say I need 4 sections here. And what I'm going to do is I'm going to download these sections from different people. Okay? So let's say I'm downloading this section. My BitTorrent client will sort of measure, and as soon as they get the full segment, then BitTorrent checks for errors. So the application is going to check for errors. If there's an error in this block, BitTorrent application is going to get another copy of the block, probably from someone else. All right? So let's say we're downloading this block, and then there's an error somehow when we're finished. We will then download it from someone else. Okay? What does that tell us about the BitTorrent client? Or the BitTorrent, yeah, the BitTorrent protocol. Oops. That doesn't look any good. BitTorrent, you can just say that. BitTorrent is then reliable. Okay? So the BitTorrent application is reliable. So that makes sense for the BitTorrent application to use an unreliable transport layer. Does that make sense? We only need one layer to be reliable in order to get the data we need. If our application is reliable, then we don't need the transport layer to be reliable. That's just a note. For the most part, most applications use a reliable transport layer process. All right, so really that was the last of layering, and that was very exciting. Hopefully that reminded us all about the layers and the passing things down and the de-encapsulation and all the other fun things about layering.